Today, in the wonderful world of function stat trig, we're going to look at what's called the inverse cosine function. So first we're going to define that, and then we're going to use what's called the inverse cosine function. Warm up you've already done. So let's take a gander here at this function right here. This is the cosine function, which is a chapter 4 concept, and we skip chapter 4 to look at right triangles, and then we will go back. So this is background stuff that if you followed the order of the book, you would know. But right now, we're just going to give you a quick background of it. So what happens with cosine is that it just goes up and down like a wave, like a sound wave. This is what the cosine and the sine functions do. So you might have heard the term sinusoidal. Sinusoidal is something that's wavering back and forth. So if you're sinusoidal on which college to go to, you're wavering. You're not decided. You're going back and forth. So sinusoidal also can describe like a wave just in the ocean as well. All right. So if we were to look at this function here, what's the domain and the range of this function? Please chat real quick with your neighbor. What is the domain, that is the values of x that work, and what's the range, the values of y that work? So I do want to show you one way that the book has been writing it is they do use the brackets, then they define the variable there, and then they put this vertical line. So in other words, it just says the domain of x is, and then we say what we're going to say in there. In this case, we can just say all real numbers, but we could also say negative infinity to positive infinity, something like that. Okay, now we're going to look at range. Range instead is the y values. And what are the y values there? Notice that the highest the wave goes is to a positive one, and the crest. That's the... Forget. The valley and the tip top, the crest. I think that's the crest in this.
We're learning that right now.
Right.
Can think of it.
Okay, so the valley there.
It's the trough, yes.
The trough and the crest.
Or is it crest and trough?
So it gets to -1 greater than or equal to y, or excuse me, less than or equal to y, and it goes all the way to 1. So it's between -1 and 1 inclusive. In other words, including those two values. Okay. Now, notice that radians are the ones on the top, degrees are the ones on the bottom. If you were to approximate the cosine of pi over 2, how would we do that? Well, let's go to, here's pi over 2, and what's the y value there? The y value there is approximately 0, because that's the y value right there. Well, what about the y value of 3/4 pi? Well, where's 3/4 pi? Here's pi. Here's pi over 2, so 3/4 pi is right in the middle. So go down. So it's there. So what would you estimate that to be over here? And that one's really hard to estimate just because there's nothing delineated there. My line might not be straight, etc. But negative what? 0.8. Maybe 0.7, 0.8. I can't even go further because I don't have enough data there to be more accurate. So, but we do know it's negative, and we do know that it's bigger than -1. So that's probably a decent one. Now chat with your neighbor. Based on the graph, what values of x make this true? That x, the cosine of x is approximately 0.75. So go to 0.75 here, and then find the values of x. So if 0.75 is approximately here, that means anything that crosses that horizontal line, including here and including here. So all these values, in fact, it goes on forever in both directions. And it's going to keep repeating over and over again. So if we were to just take a guess at where this might be, I don't know exactly where this is. And I wouldn't leave it in terms of pi. I could leave it in terms of degrees because it's probably a little bit easier to do degrees in this case. So if this is the x value and 90 is right here, that looks like a third less. So I'm just going to take a shot in the dark and think it's about 60. Yeah. And then over here would be -60. And then over here, on the other, as it keeps going, what would that be? There's my other answer. So 270. So my guess is closer to 300 degrees. But notice that X could be 60 degrees, negative 60 degrees, 300 degrees, and forever. It goes forever in both directions. So that does create a small little dilemma for us. Because there's an infinite number of possibilities when we're undoing cosine, it's best for us, when we are doing the inverse of cosine, to limit the domain here. So since the inverse of cosine of x yields an infinite number of values, we need to restrict the domain. So since the inverse of the cosine of x yields an infinite number of values, we need to restrict the domain because then it wouldn't pass the vertical line test. Again, just as a quick note, this isn't reflected, but here it doesn't pass the vertical line test, so I have to be able to restrict it a little bit. So here are some criteria for things to include. Number one, please write that. I meant to say included angles that are between. So I'm not saying restricted only, but it's got to include the angles between. If we're talking radians, it's 0 and pi over 2. The reason for that is because that's 0 degrees and 90 degrees, which on a right triangle, that corresponds to the acute angles of a right triangle. So one criteria is that it's got to be between 0 and 90 degrees, or 0 and pi over 2 radians. We want to include all the values of the original range. So the range of the cosine of x. So notice, as we talked about it earlier, the range here is the crest is 1, the trough is -1, so it's got to include all those values. So we want to find a section of this curve that includes all the way from the top all the way to the bottom. So it's got to include all of those. It doesn't say how many times it has to include it, but it does have to include it. And lastly, the function should be what's called continuous. No breaks. Okay, so in thinking about this, the only domain of my function. Now, by the way, the function that we're talking about is called the inverse of cosine. This is how we write it, with cosine with a -1 above. I do want to point out that this does not mean, do not say the cosine of x to the -1. That's not what we mean, okay? These are two separate things. This right here means fractionize, like this means make it into a fraction. This one here is inverse. Slightly different. Okay, so the only domain that fits these criteria in terms of radians is 0 all the way up to pi in radians. And that corresponds to 180 degrees. I may or may not have mentioned this, but this function is also called arc cosine with a double C. Arc cosine. Sometimes you're going to see that. You might also see arc sine and arc tangent. Okay? That's just an older way of saying what we say now. Probably, I wouldn't be surprised if it had to do with, typewriters. When they were doing printing presses back in the olden days before the computer, they couldn't get the exponent there so easily, so they had to just write it out like this, okay? So you might see it like this. You might also see it as capital arc cosine. That actually means something slightly different. That just means the bounded function. This would be the non-function that goes forever like that. and this would be the bounded function. Anyhow, we're not going to see that much, but on old calculators, I have seen that before. So arc, cosine, and cosine to the -1 all read inverse of cosine. All right, so this is the definition of the inverse of cosine. Y is equal to the inverse of cosine of x if and only if x is the cosine of y, and we're talking about a restriction here. We're only talking about this domain in terms of radians. Again, that's radians, or 0 to 180 degrees. As I mentioned earlier, the inverse of cosine is sometimes called the arc cosine, like so. All right, this first example, I want to show you how to use your calculator. We're going to find the approximate values of each in radians and in degrees. So what you're going to do with your calculator, you're going to press the second button, the cosine to the inverse cosine, which is above the cosine, and then enter in our value, end parenthesis. If your calculator's in radians, that's going to give you it. If your calculator setting is in decimals, that's what it's going to give you. So the first thing I did here was degrees. My calculator was set to degrees, so that is 30 degrees. If you go back to your chart, which is something called the unit circle, we actually have the answer because we can just convert straight to be pi over 6 radians. That's an exact answer. That's something that you will eventually memorize as part of the unit circle, which we have not done yet, but you already have a chart that has some of that. But if you wanted to do on the calculator, you would end up with an approximate value. So you just reset your calculator to radians. So when we plug that into our calculator, we get approximately 0.5236 radians. Again, this is an approximate value. Sometimes the book is going to ask you, or anytime it says, without a calculator, do this. For now, do the calculator, because we haven't memorized the unit circle yet. So use the calculator, and feel free to leave it as this answer right here. Sometimes the back of the book is going to give you as this answer. So if you do degrees first and then use the table to convert it, that's fine too. Or just plug it into here. So I will be testing you in this method. That's mostly how to use your calculator, not this method on memorization yet. What angle does the ladder make with the floor in this diagram here? So we have a 16-foot ladder, and the foot is 3 feet away. So we want to find out what theta is. So we just look to see what we know relative to theta. This is my adjacent. This is my hypotenuse. So therefore, I'm going to use cosine. So the cosine of theta is equal to 3 over 16. I gave myself some space there because I knew I was going to take the inverse of cosine. So notice I take the inverse of cosine, like so. And now, on the left side, the inverse of cosine and cosine drop out, and we're left with theta, which is an angle measure. And I'm going to put an approximate value here, because when I enter this into my calculator, I should get an approximate value. Before we even do that, though, just based on the diagram, what do we expect our angle to be? Right. So, approximately 79.2 degrees. The answer does not tell me whether to leave it in degrees or radians, so be prepared for both. So that's degrees, and if I just do a quick conversion to radians, I can get that as well. Again, it doesn't tell me which to leave it as. Context is important. If other places have degrees on it, then my answer is degrees. If it starts out with radians, then start with radians. Of course, if we're talking a practical situation like to your little brother, most likely you're going to say degrees. So context is super important. But just be prepared to be fluent in both methods. All right, it's your turn on example number 3 here. Please make sure to convert your inches to feet or feet to inches, whatever. Just make sure that you have fluid so that you can enter things into a calculator a little bit easier. So this would be the work for here.